Welcome to a lesson on radian measure. The goals of this video are to define radian measure, convert angles from degrees to radians, and from radians to degrees. Just as it sounds, a radian is based on the radius of a circle. 1 radian is the angle created by bending the radius length around the arc of a circle. As we see here, the radius in red is the same length as this red arc, and therefore this is an angle of measure 1 radian. So because a radian is based on the actual part of the circle, rather than an arbitrary division, it is a much more natural unit. Now remember that the circumference of a circle is 2 pi radians, so it follows that 2 pi radians is equal to 360 degrees. So if we took this equation and divided both sides by 360 degrees, we could show that pi radians over 180 degrees is equal to 1. If we divided both sides by 2 pi radians, we could show that 180 degrees divided by pi radians is equal to 1 as well. And these are the conversions that we will use to convert radians to degrees and vice versa in just a couple minutes. However, let's first take a look at a Wolfram demonstration. What we see here is a 30-degree angle in standard position. And if we divide 30 degrees by 360 degrees, we would see that that is 1/12 of the whole circle, or 1/12 of a full revolution. So therefore, if we wanted to convert 30 degrees to radians, we could multiply 1/12 by 2 pi radians to get pi over 6 radians. So in this animation, as we change the angle, at the same time we see the conversion to radians. We'll stop here at 90 degrees, and we can see that 90 degrees is 1/4 of a revolution. Therefore, 1/4 times 2 pi would give us pi over 2 radians. And you can see this also marks off the number of radians on the outside. Again, this just shows a relationship between angles and radians. And again, we see 360 degrees is equal to 2 pi radians. And a similar relationship occurs when we have negative angles. Let's go ahead and convert some angles in degrees to radians. And what we do is we're going to multiply the degree measure by pi over 180 degrees and then simplify. Well, of course, some of these we should already know, meaning by definition, 360 degrees is equal to 2 pi radians. And of course, 180 degrees is half of 360 degrees, so half of 2 pi would be pi radians. Let's go ahead and show this one by hand. It's helpful to put 90 degrees over 1 and then multiply by pi over 180 degrees. And we need to simplify this. This simplifies nicely. This simplifies to 1, this simplifies to 2. Notice the units of degrees simplify out, and we're left with pi over 2 radians. Similarly, 45 degrees is half of 90 degrees, so half of pi over 2 would be pi over 4 radians. And I'll go ahead and show this one as well. 30 degrees over 1 times pi over 180 degrees. Simplifying. 30 degrees is equal to pi over 6 radians. And that's important because a lot of the angles that we will encounter will be multiples of 30 degrees, and therefore multiples of pi over 6. And 60 degrees is 2 times 30 degrees, so we could just take pi over 6 and multiply by 2, or double it, and get 2 pi over 6, which is pi over 3 radians. But if we're ever not sure of the conversion, we can always just multiply by pi over 180 degrees. Let's do the opposite now. We'll convert from radians to degrees. And notice often when an angle is given in radians, the units are not given. It's assumed they're radians. Again, 2 pi radians is equal to 360 degrees. That's a given. Half of 2 pi is pi, so half of 360 would be 180 degrees. And let's go ahead and show this one. We want to convert pi over 2 radians to degrees, so we'll multiply by, this time, 180 degrees divided by pi, and simplify. Pi simplify out. This simplifies to 90 degrees. And again, the relationship here, pi over 4 is half of pi over 2, so half of 9 degrees would be 45 degrees. And again, this is important because if we have an angle that's a multiple of 45 degrees, we will have an angle that is just a multiple of pi over 4 radians. Pi over 6 times 180 degrees over pi. Again, the pi's simplify out. There are 30 6's in 180, so this would be 30 degrees. And pi over 12, pi's are out. 180 is the same as 12 times 15, so this would change to a 1, this changes to a 15, and we have 15 degrees. So when you're first learning to work with radians, one thing that can be very helpful is to remember two key angles in radian measure. And the first one is 30 degrees is equal to pi over 6. The reason that's important is because if we have an angle that's a multiple of 30 degrees, it's going to be a multiple of pi over 6. So 60 degrees is 2 times 30 degrees, so it would be 2 times pi over 6, or 2 pi over 6, which simplifies to pi over 3. 90 degrees is 3 times 30 degrees, so it would be 3 times pi over 6, or 3 pi over 6, which simplifies to pi over 2. 120 degrees is 4 times 30 degrees, or 4 times pi over 6, which simplifies to 2 pi over 3, and so on. So this is actually a very helpful diagram when you're first learning how to work with radians. The second key angle would be 45 degrees being equal to pi over 4 radians. So if we have an angle that's a multiple of 45 degrees, it will be a multiple of pi over 4 radians. So since 90 degrees is 2 times 45 degrees, it would be 2 times pi over 4, which simplifies to pi over 2, and so on. So these two diagrams might be very helpful for some notes.